Hi guys, do you know that a human body of average weight of around 70 to 80 kilos of weight is having around 7 to 8% of the total body weight in the form of blood, and the blood flows with an average blood pressure of around 120 by 80 corresponding to the systolic and the diastolic blood pressure and having a pulse pressure range of around 40 mmHg, and this blood flows around 170 to 180 cycles per day, and that cycle leads to the transfer of the blood throughout the body in the day. But have you ever thought that why the blood is not clotting when it is flowing inside the blood vessel? It makes very interesting to know that how this blood is clotting when the blood vessel is damaged. That means when the blood comes out. Can you believe our body produces 10 to the power 6 to 10 to the power 11 number of microclots in the microcirculation, but still they are not creating any problem. As you know that these microclots, if they are formed in the brain or in the microcapillaries of the lungs, in the liver, then they may lead to stroke like symptoms, and the part where the clot will be formed, it will not allow the flow of the blood. But in normal case, in physiological processes, these clots are being removed continuously. That means body has developed a self-defense mechanism by which it will not allow the formation of microclots. You can say these are known as the intravascular blood clot or the thrombi, and when these thrombi are moving inside the blood vessel being known as the emboli in contact with any foreign organism, even they are not creating any problem as such, but there are certain states are there when deviation occurs, and this leads to the formation of occlusions and ultimately lead to infarction in the heart or hypoxic driving in organs. So with this very introduction, Dilip is today with a very interesting topic that why blood doesn't clot inside the blood vessel, how dynamically the blood vessels have evolved, and they have evolved several mechanisms to protect the blood to form small clots. So before going into the details, please like my channel, subscribe my channel, and let's come to further digging into the deep part of this. So if you see the blood vessel, I am drawing a simple diagram to show you what actually happens inside the blood vessel. This what you are seeing, the inner lining of the blood vessels, and this inner lining of the blood vessels is known as the endothelium. It is single layer of simple squamous cells which are flat and having a distinct nucleus. These are actually said to be cells, but truly saying they are capable of forming or doing the functions of entire blood vessel. So that's why they are also known as a complete blood vessel cell. And if you see this epithelium, this is known as endothelium, and this endothelium is showing the presence of these endotheliocytes. These endotheliocytes are also known as the endothelial cells, and these are the cells which behave like complete blood vessel. And just why I'm focusing on this, because this is that master regulator which is protecting us from forming a clot as such in the normal circulating blood. The blood is circulating here. It may go tangentially, it may go in the streamline depending on the situation or the need of the body, but there is formation of no clot. And this endothelium, usually it is smooth, very smooth. This point has very important point. Second, it is having a covering of glyco calyx. That's what known as a mucopolysaccharide layer, and this mucopolysaccharide layer makes the endothelium to become negatively charged. So these 3 points are the first point which regulates the blood continuous blood flow without clicking of the blood cells, platelets, or the coagulation factors to the inner lining of the blood vessels. But that this smooth point, this smoothness of the endothelium, this does not allow the clicking of platelets. This is one of the important points they don't allow. Number two, That means adhesion of platelets platelets is absent. This doesn't allow the clotting factors to become active. That means the factor number 12, that's known as the Hageman factor, which initiates the intrinsic mechanism of clotting. It is the rate initiating factor. If this will remain inactive, then the intrinsic mechanism of clotting will not occur. Guys, for intrinsic mechanism, please go to my coagulation of blood cascade or mechanism of coagulation lecture. You will get the details. So the limiting points what I have written here, those are the limiting points which says that the smooth surface is one of the most important point, and along with this there is these endothelins, which are the specific secretions of the endothelial cells. They also do not allow the platelets to adhere, and also they keep the clotting factors inactive. So this is the first point. Second, when I am saying this glycocalyx, which is the mucopolysaccharide coat, if I can draw here, it is just like this. This is the mucopolysaccharide coat which is there over the endothelial cells. It will not allow the attachment of negatively charged flowing cells, which are the prerequisite for the formation of the clot. That means surface is negatively charged. Here it is also negatively charged. So negative charge, it causes, this point is important, repulsion of cells. That means cells do not come in contact with these endothelial cells. So the take home message or the summary point is that endothelium, intact endothelium, it plays very important role. That means the opposite point I'll say now, if the endothelium is damaged, the surface becomes rough, and that rough surface serves as the site of contact of platelets, site of adhesion of the platelets, and number of clotting factors are activated. Already I have mentioned one, but I will tell you several other factors, and then that process will initiate the activation of the formation of the thrombin, and followed by the conversion of fibrinogen to fibrin and its accumulation, leading to formation of a clot. So therefore an intact endothelial surface is the first point which protects most of the intravascular clotting cascade. Next we are coming to the number 2 point, and that number 2 point is everybody knows, but yes, I want to focus on that. That is, this is, suppose for example, this one is the number 1 point, then number 2 point I'm saying, number 2, that is presence of heparin. I'll tell several points, and these are some of the important points. Heparin is another polysaccharide. We can say it as it is another mucopolysaccharide molecule or conjugated polysaccharide, and it is synthesized in the hepatocytes of the liver, and it is said to be a potent anticoagulant. But I will tell you a miraculous point today. This heparin, it is secreted from the mast cells in the connective tissue. This comes as a question. So important, mast cell, MAST, mast cell, or it is secreted from the basophils in the blood. So these are the two cells which are regulating the release of the heparin. It acts as an anticoagulant. It is wrong to say, rather you should remember, and the message should be very clear. Heparin is said to be a inactive or less potent intravascular clot anticoagulant. Remember this. It is wrong to say that it is a potent anticoagulant. Rather, it combines with a plasma protein which is present in the plasma, and that plasma is known as the antithrombin 3. And due to that antithrombin 3 combination of heparin, the heparin becomes 100 times more potent anticoagulant inside the blood vessel. So I am writing here this heparin, once it combines with this antithrombin 3, then it becomes most potent anticoagulant. This is that point which I wanted to convey you people, that it acts as a potent anticoagulant, and around 100 to 125 times the anticoagulation ability increases. So we have to remember antithrombin 3 is the measure which combines with heparin to increase its anticoagulant function. So that's why. So first I told that smooth layer of endothelium. Endothelium is playing the important role, and then I started talking about the heparin. So now see what other points are there. Now I'm coming to the third point. This third point is understood by everyone, but we have never considered that how this point is important, because several points will come from this very important point. So let's focus on this. I'm making a chart to make it more clear for you people. So the point is that is coagulation or clotting factors. As you know that in the blood there are 13 clotting factors are there, starting from 1 to 13, and there are several others are also there, no doubt about that. But all these clotting factors except the fourth clotting factor, that is calcium, they are all present in inactive form. That means through stages of activation they get activated, and once one is activated it will cause the activation of the other. That's known as the cascade theory or this waterfall theory of activation. So once they are present in inactive form, they will not allow the formation of the prothrombin activator. This is a master point. So they will not allow the formation of the prothrombin activator. This prothrombin activator, it converts the clotting factor prothrombin to the active compound that's known as thrombin. And as you know that master molecule of clotting is the thrombin. How? Now this thrombin acts on this clotting factor. We will discuss in detail, and you can visit my lecture as well. This fibrinogen is converted to fibrin, that is in the presence of thrombin, and this fibrin polymerized like this. These are monomeric fibrin threads. They are polymerized, and that polymerized mass occurs in the presence of factor number 13, that is fibrin stabilizing factor. So in the presence of this, there is formation of a clot. What you are seeing under the microscope, a meshwork of fibrin threads, that's known as the clot. So what I am saying, as the clotting factors are present in inactive form, and there is absence of this prothrombin activator in the normal circulating blood, or due to the absence of the thrombin in good amount, what happens? Now normally fibrinogen is not converted to fibrin, and fibrin is not further polymerized to form the stable clot. So this is one of the most important point. Next, the third point is the platelet count is also less in normal circulation. Once there is injury to the blood vessels occur, these platelets are released in more amount from their stored part, maybe from the spleen, from the red bone marrow. They come to the circulation and they get active. Next, the point is that platelets, they are inactive. That means you know that 1.5 to 2 million number of platelets are present in the cubic ml of blood. These platelets are not complete cells, they are fragmented cells which are derived from the megakaryocytes, and after the fragmentation they have lost their nucleus and cytoplasmic organelles are present. Even the calcium storage granules and the calcium channels are also present inside the platelet. That makes the platelet very specialized. The platelet contains a plethora or an array of clotting factor activators and several proteins which will promote the clotting. For details, you visit my platelet lecture. So what happens now, once the platelets are released into the blood, they behave inactive, or they are inactive, and the smooth endothelium doesn't allow them to get activated, along with several other factors like antithrombin 3, protein C. There are several factors are there which will not allow the platelets to activate, adhere, and to become active to carry out the process of cascade, blood clotting cascade. So that's why I'm saying the platelets are inactive. They are also, the next point is that the platelets are intact or degranulated platelets. That means the platelets are storing their granules and they are intact. That's why they do not show degranulation, and hence the clotting cascade is not activated. So why I'm saying now, this heparin, once this heparin is there, this heparin combines with, as I told, that is antithrombin 3, and it chelates several factors like 11th, 9th, even 8th, and these factors, once they are chelated or bound or removed, they will not allow the process of clotting cascade to be active. So the take home message is that when the blood vessels are intact and the blood is flowing inside the blood vessel, the clotting factors remain in inactive form. Their activation occurs when the surface of the endothelium is ruptured or they are being exposed to outside, the collagen is exposed to outside, then the clotting cascade is being activated. So therefore, inside the blood, inside the blood vessel, it is very difficult for the blood to form clots. Let's come to the next point where we can discuss what actually happens further. Means some other points are also there which will support our concept. So after discussing 3 important points, now I am coming to the 4th important point, that is this protein C. Protein C. This comes as a question. It's a plasma protein. Of course, it is coming from the hepatocytes. It's a marker protein, and this marker protein that is activated by endothelial thrombomodulin. This thrombomodulin is a protein which is secreted from this endothelium. That's why it is known as endothelial thrombomodulin. Once this endothelial thrombomodulin is secreted, it also causes activation of a factor which is known as protein C. This protein C is known as an anticoagulant factor or agent. That means in the normal endothelium, this agent is secreted, thrombomodulin, which activates this master protein which is originated or circulating in the plasma, and due to the activation of this protein C, the anticoagulant mechanism remains active, and therefore in the normal circulating blood it is difficult to get the clotting of the blood. So this is number 5 point. So I am coming to the number 6 point, because you know that whenever there is damage is there to the endothelium, then this endothelial release of thrombomodulin is almost negligible or decreases, and thereafter this mechanism stops. So this is a take home point. Next, as I already told, still I am writing that the 6th point which says intact endothelium, it doesn't allow, this point is important, doesn't allow the activation of factor number 12. It is already I have said. So it has been seen that this anticoagulant factor, this protein C and this inactivated 12, it will further stop the intravascular clotting mechanisms. So these two are simultaneously important. That's why I'm writing they stop intravascular clotting. That means nature, body are having those things which are required them to protect. And you can see well that how protein C is interacting with an inactive 12, and thereby this intravascular clotting is being inhibited. Okay, now I'm coming to the 7th point, and that 7th point is another important point. We'll discuss around 10 points. So the 7th point, as a student you must know this, so that's why I'm saying. Okay, the 7th point is this enzyme, plasminogen, this is a hepatocyte origin enzyme which is activated to plasmin. This activation occurs in the presence of tissue plasminogen activator, and this tissue plasminogen activator TPA, it causes formation of the plasmin. The plasmin is classified as a fibrinolytic enzyme. That means it causes the dissolution of fibrin polymers, and that's known as clot lysis, or we can use this word fibrinolysis. Due to this, these microclots which are formed, as I told in the introduction, when these microclots are formed, they undergo lysis. So this is one of the important factor. This plasminogen, it is always present in inactive form, but whenever there is a clot is formed, it gets activated and converted into plasmin, and the converting enzyme is known as the tissue plasminogen activator. This tissue plasminogen activator leads to the formation of the plasmin, and this converts the plasminogen to plasmin, and which acts as a fibrinolytic enzyme. So this is another factor for all of you. I think this is the 8th factor which is playing the most important role in the process of non-coagulation of blood inside the circulating blood vessel. Next, I am coming to the next point, and that point will finish this discussion why the blood is not clotting inside the blood vessel. These are some of the dynamic points which are now coming, and that dynamic points we'll discuss one by one. Just have a see. That is, this is the 9th point, surface to surface repulsion. As I said, next, cellular cytoskeleton. They also do not allow the cells to fuse with each other. Third, fibrin formation is dramatically low when the blood vessels are intact. This is 10th point, this is 11th point. 12th, intact and inactive platelets do not adhere to each other, because once they will adhere to each other, then the clotting cascade will begin. They are the foundation stones for the clotting. They once they will accumulate at a point where they will stick to each other, then the fibrinogen is converted to fibrin by the thrombin and gets deposited there. So that's why this point is one of the important point which will not allow these cells to click to each other. Cellular cytoskeleton, already I told that when the endothelial cells are intact and platelets are flowing, as you know that they are the fragmented cells, but their cytoskeletal elements are poor. Their mitochondrial enzyme system is also inactive. That means this mitochondrial ATP production is also very less, and glycogen granules, what you are seeing inside the platelets, they are not utilized. So these points make it very, very sensitive for this process, that they will not allow the clotting process. Next, another last point, the 15th point, the vascular endothelium, that means once it is intact, endothelium shows failure of, this point is important, failure of micro contractures. These micro contractures are seen when the blood vessels are damaged, and the point of damage, the smooth muscle shows small degree of contraction. That contraction tries that more flow of the blood should not be there, but instead it attracts the cells to come that point and adhere to each other. So in the intact endothelium, intact smooth muscles, they are not going to show micro contraction. With this particular point, this lecture came to an end. And in this lecture, we have gathered so many points where we have tried to understand that how the intravascular clotting is prevented. In spite of all this thing, still sometimes due to overproduction of the plasminogen, plasmin, sometimes clotting occurs, and once inside the blood vessel a clot occurs, that's known as thrombus. It remains attached and clog the flow of the blood, and the process is known as thrombosis. Once it will start moving inside the blood vessels, it is known as embolus or emboli in plural, and the process is known as embolism. So that's why I said that for the detailing of this lecture, you can go to the coagulation cascades and you will try to understand how intrinsic and extrinsic mechanism, how inactive platelets to active platelets, they play the important role in the process of blood clotting. So stay tuned for my next lecture and keep learning. Before leaving this channel and learning, please put a like and subscribe my channel. Thank you so much. Stay tuned.